Welcome everybody to our week 2 of Grad Stats, University of Cincinnati. This is our lecture 2 of week 2, Introduction to Data. Throughout the course of the semester, I'm gonna introduce you to a variety of studies in order to help you appreciate some important concepts in research and analysis. Consider for now the study called Alcohol Brand Use and Injury in the Emergency Department. The study was published in 2013. Now, when we're faced with a new study, perhaps the first question you should ask yourself is, what is the population of interest? That is, to whom do the researchers wish to generalize the data to, or the lessons of the study to? You typically find that information in the introduction of a research paper, for instance. That's where the researcher presents their research question. The research question driving this particular study was, are consumers of certain alcohol brands more likely to end up in the emergency room with injuries? The population of interest implicated by this question is all alcohol consumers. So this would be the desired scope of inference. Another thing to consider when, again, faced with a new study or with a data set is what is the sample that was actually used? What is the characteristic of the individuals that were actually studied, that actually participated in the study, that actually provided us with data, the source of data? In the sample, we read about what the sample is, typically in the method section of the paper. In this case, the sample was constituted by patients at the Johns Hopkins Hospital in Baltimore, USA, that were admitted to the emergency room. These particular patients were drinking within 6 hours from their admission, prior to their admission. I hope you are noticing a discrepancy between the population and the sample. And that discrepancy restricts the potential to generalize the findings of the study. Even though, the ambition of the authors might be to generalize to all alcohol consumers, the fact that they just studied participants or patients in the Johns Hopkins Hospital in Baltimore might create some biases in the results that are very specific to that particular set of people, right? So the actual population that the data applies to or generalizes to, it's not everybody, but alcohol consumers that are residents of Baltimore. And this is so because certain brands may be more easily available in this area than other areas due to particular trends in the market and market share. Maybe there is some transient effect due to a particular brand being on sale, different things that could introduce idiosyncrasies in the data, such that whatever recommendation comes out of this study, if there is a particular brand that is especially dangerous and favors accidents that lead to that takes people to the emergency room, I cannot, this particular data set does not allow recommendations that are general for the entire country, for the entire world. The recommendation should be more local, right? Applicable to residents of Baltimore only. Census versus sample. A census, differently from a sample, looks at or examines the entire population of interest, not only a piece. When we have a sample, we have a piece of the population, right? Now, given that the goal of a study is typically the study that takes a sample from the population is to generalize to the population, is it the case that sampling is always worse than census by definition? Now, to answer this question, I wanted you to think of an example of sampling in our day-to-day life. When do we sample things? One common one for me every night when I'm cooking and I'm at the end trying to see if the salt is okay, if I need to put a little bit more maybe pepper or some other kind of seasoning, what do? Do I eat the entire dish, or do I just take a small portion in order to determine whether I need to put more salt or not? We typically just take a small portion, right? And that is informative of the entire dish. I can take my little portion, try it, and then say, maybe it needs a little bit more salt. And then I put more salt. Maybe I try it again and say, okay, that's good, time to serve, right? So sampling is an effective method, and it's also a more cost-effective because it's kind of expensive. If every time you were to try and answer a question, you would have to go in and examine the entire population to which you would like to generalize, right? Certainly in the case of cooking, that would be a bit of a problem, right? However, sometimes sampling does fail. And let's go back to our example to consider when might it fail. When you're sampling, you're cooking and you're sampling a little piece, a little part of your dish to determine how you should season it a little bit more maybe. When can it fail? One thing that can make it fail is if there is a concentration of salt, let's say, in a particular part of the sample, in a particular part of the dish, and then you try that particular piece, and then you go, oh my gosh, it's actually very salty, I don't know, this is not good today, definitely no more seasoning. But it may be the case that in other parts of the dish, it's saltless and tasteless, and it would be nice if you would put a little bit more seasoning in there. So what's going on here? What is going on is that the piece of the food you sampled is not representative of the whole dish, right? So when you're sampling, when you're cooking, you need some procedures in place to guarantee that you're sampling appropriately. For example, we might want to stir the dish. In Brazil, we eat lots of beans, sometimes with sausage inside. So we would, mix a little bit before we would try it, right? Because if it's steaming for a little bit, you may get more sausage on one end and that little spot become a little bit more salty maybe. So you want to stir it first before you sample, right? So you need to do things to make sampling effective, to guarantee that, or to increase your chances that the sample that you're extracting is representative of the whole thing you want to generalize to, right? In this case, the sample, the little piece of food that you're taking is representative of the whole dish. And in the case of research, that the set of people that you're examining is representative of the entire population of which they are part. Key thing to remember here then is that a sample, a good sample, represents well the population of interest. At least in the aspects that you're interested in, right? Sources of sampling bias in research. Sometimes we use what we call, it's not that infrequent that researchers use what we call convenience sample. And those are individuals that are easily accessible to the researcher. In the example we gave, the researcher was probably from Baltimore, maybe they worked at the hospital in which the sample was obtained, so it was convenient to select that particular sample. However, they may share a particular feature that the population in general does not. So I've conducted some work, for instance, in Brazil, in which we would study children with disability and compare their performance to children typical children. And the children with disability would come from the hospitals that my university was connected to. And the sample of typical kids was typically a convenience sample that we would obtain through contacts we had through our own kids' school, so on and so forth. The issue that this can generate is that a particular bias sample can be obtained because people would be more or less of the same social cultural background of the researcher instead of representative of typically developing kids in Brazil. So the other source of sampling bias is non-response. So if only a non-random portion of the randomly sampled people respond to a survey, for instance, it is no longer representative of the population. Here's one example. Imagine you find a way to randomly select a number of elderly people in Cincinnati to respond to a survey because you want to generalize your results to elderly in Cincinnati. Or imagine you want to find out something about graduate students at the University of Cincinnati, and you find a way to randomly sample from that population. And then you send surveys out. Even if you used a very sophisticated randomization procedure to select to whom you would submit the surveys, if there is a large portion of people that does not respond to the survey, if the percentage of non-response is too high, you no longer have the representative population that a sample that's representative of the population that you began with. Okay, and this is because a particular set of people might be compelled to respond to a particular kind of survey. Maybe imagine if you want to know how involved students are with diversity initiatives in the university. If you send this out, maybe it is going to, maybe the students that are from underrepresented minorities will be more likely to respond, and they may bias the results to very involved. But it's not necessarily that they're more involved. It's more the case that less, white folks responded to the survey, for instance. Does that make sense? Voluntary response. This is another one that can cause sampling bias. If the sample consists of people who volunteer to respond, they're not even selected in advance by the researcher. So that's different from non-response, because non-response, the researcher has good intentions and guarantees that the sample has, similar percentages of people that the population has. But voluntary response, you just send something out there. You don't even select, and then people volunteer to respond. And then in this case, results may be biased because the sample might end up with only one portion of the population that more deeply care about the issue, right? Same thing with the non-response situation. So the result might, end up being the same, even though in one, there is an effort of the researcher to get a representative population. If there is a high non-response rate, you need to be careful about that. And voluntary response is already, it doesn't begin well, right? Now, one question to see if you got this: to what kind of bias are Facebook surveys subjected to out of these three? If you're thinking voluntary response, you got it right, because typically what people do is that they post a question about something they want to find out on Facebook. Examples are, who are you going to vote to find out whether Democrats or Republicans are going to be more likely to win local elections, for example. However, as you can imagine, if you are a Republican, you're likely to have more Republicans around you, and those are probably going to be more likely to respond to your own survey, and you may end up with a biased result. Similarly, if you're a Democrat, you're going to probably be surrounded by more people that think alike, and they will be more likely to be pulled to respond to your survey. So you may end up in the end with the wrong result due to sampling bias. This is it for now. I'll see you on the next video.